In this video, I'd like to show a couple of examples of finding integrals using the exponential form. So the exponential form tells us that the integral of e to the u, where u is some function of x, multiplied by du is equal to e to the u plus c. So notice the u is up here in the exponent. And so that's our u. And what we will begin, as we have in many other examples, is saying, okay, then u is equal to 2x. What is du then? So du by dx is 2. But we need just du, and so we take that one step further. Du is equal to 2dx. Now if you notice, I've got my e to the u in the formula, e to the u, and then I just have 1 as a coefficient dx, 1 dx. But over here, du is equal to 2 dx. So what we need is some multiple of our du that is equal to 1 dx. And I do that, convert this 2 into a 1 by dividing that side by 2, and we'll divide this side by 2. And we find it a little bit easier to write that as 1/2 du is equal to dx. So what we found is a multiple that we must multiply this integral answer by to get the correct multiplication factor. So now that I have found that, I can now say, okay, then this is equal to 1/2 e to the 2x plus c. And if you try to take the derivative of that, you will find that you get back to this integrand that we started out with, e to the 2x. Okay, so let's take a look at another example. I've got 5x multiplied by e to the 4x squared dx. And remember, with a u and a du is a differential of u. And so the power from u changes from 2 to 1. And so that's an indication that this method is going to work. And we don't need a different method to use. One of the things I always suggest is to keep it from being too complicated is to remove any numerical coefficients from the integrand. So that's going to come out here, and I will rewrite my value like this. Okay, so 5 is going to get multiplied by the answer that we find from here at the end. Now we just have a little less inside the integrand to be focused on, but we will approach this the same way. U is equal to 4x squared. And therefore du is equal to 8x dx. Well, if you notice, there's my e to the u, just like the formula, and the rest must be a multiple of du. Well, we've got 1x dx, and du is actually equal to 8x dx. So this du is 8 times too much, so we must divide by 8. And that will get me 1/8 of du then is equal to the proper value that is in my integrand, 1x dx. So I have found the correct multiplication factor that I need to multiply the answer by. I also want to remember I'm multiplying by 5. So my final answer will be 5 multiplied by 1/8. And now it fits, and I can use the formula for that, which is e to the u plus c. So e to the 4x squared plus c. And that will simplify down to 5/8 e to the 4x squared plus c. And that's a couple of examples of how to do integrals with the exponential form.